Okay, next is surjective onto and into function. Next classification na onto and into function. Okay, so second one is onto, other name of this one is surjective. And into function. Okay, now what is the onto function? Suppose for any function f a to b, if each element in b have at least one pre-image in a, okay, if each element in b must have at least one pre-image in a, then function is onto, otherwise into. Okay, for example, pictorially, if I take function a to b, now suppose if a is connected to 1, b is connected to 2 and c is connected to 3 and d is connected to 4. Okay, now in this example, each element of b have at least one pre-image na, one pre-image of 1 is a, pre-image of 2 is b, pre-image of c is 3 is c and pre-image for 4 is d. Okay, so each element have at least one pre-image, then this one is onto. Okay, now suppose this one. Now in this example, here we have one element in b which has no pre-image. There is no pre-image of 4. Okay, if in b you have any one element which has no pre-image, then this is not onto, then this become into function. Okay, so this one is into. Now suppose here if you this one. Now again, in every element in set B has at least one pre-image, has 3 have 2 pre-image, no problem, okay, but we want at least one pre-image. So there is no any element which did not have any pre-image. Okay, so this is also onto. Okay, so just simply condition is if each element in B must have at least one pre-image in A, then function is said to be onto, otherwise into. Okay, if you want to prove that any function is into, then just find one element in B for that there is no x in A, or just find one y in B for that no x in A. Okay, this is. Okay, now if I write the definition, then a function f a to b, if a function f a to b is such that each element in B, B means codomain, must have at least one pre-image in A. Okay, if each element in B must have at least one pre-image in A, then function is said to be onto. Okay, else into. And also thus, in other word, if you take any value of y from B, okay, for any value of y or for all value of y from B, if there is a x in A, then you can say that this one is onto. Okay. A to B is said to be onto if for all y belongs to B. For all y belongs to B, if you take any value of y from B, there must be one x in A. Okay. Onto if for all y belongs to B, there is at least one x belongs to A such that fx equal to y. Okay. For any value of y from B, we want at least one x in A such that fx equals to y. Here fa equals to 1. If y is 2, then fb equals to 2. It means x is B for that. If y equals to 3, then here we have na fc equals to 3. So we have at least one x such that fx equals to y. Here fd equals to 4, like this one, then on to. Okay. Now also one thing. If you want to prove that function is into, just find one y in B. For that there is no x belongs to A. Just simply. Okay, we will take question based on this one, but this is okay na. So to say into, what we have to prove, we have to just find one y in B such that there is no x in A. For that, no corresponding x in A. Okay. And also one thing, how to prove that a function is onto. Okay, there is only one method. If you want to prove that any function is onto, first find the range. Okay, what we have to find? Just first find the range of the function. If range of the function is equals to codomain, then function is onto, otherwise into. In this case, codomain is B always. A to B na, then B is codomain. In this one, range is 1, 2, 3, 4, all possible value of y, that is equals to B, so onto. Okay. In this one, range is 1, 2, 3, because 4 is not value of y na for any x. Okay. So 1, 2, 3, that is not equals to B. Okay. So this one is into. Okay. Again 1, 2, 3 is the range, that is equals to B, so onto. Okay. So remember, if range of f is same as codomain, then f is onto. Okay, then f is onto. And another thing you have to remember, if any polynomial function is given, then directly you can identify that that function is onto or into. Just check the degree. Okay. If degree of the polynomial function is odd, then function is onto. If degree of the polynomial function is even, then function is into. Okay, what is the degree? Degree is the power of degree is the highest power of x in the polynomial. Okay. So all odd degree polynomial function are all odd degree polynomial functions are onto, and all even degree polynomial functions are into. Okay. If there is a polynomial function is given, then just check the degree. If degree is odd, then function is onto. If degree is even, then function is into. And how to identify that function is onto or not? Just find the range. If range is equals to codomain, then onto, otherwise into. Okay. Can I have? Okay. If you want explanation for this one, then 1 minute. First write this one, then I will give you example. Okay. Can I have? Okay. So if you want that, how I can say that if a degree is odd, then function is into, if degree is even, then function is onto. Just take any polynomial function. Okay, choose any polynomial function of odd degree. Okay, suppose I am taking x power 9 plus 7x square plus 1. Degree is odd now, highest power of x. Okay, in this function, so degree is odd. Now just try to draw the graph. One thing is clear, polynomial function is always continuous. Okay, now you can't break this one. So put minus infinity. If you put minus infinity power 9, minus infinity. Okay, na, only highest power matter. So minus infinity. Now put plus infinity. Then plus infinity power 9 is plus infinity. Now this is the polynomial, so join anyhow, doesn't matter. But now see, range of the sun is minimum value is minus infinity and maximum value is plus infinity. So it is taking all value from minus infinity to plus infinity. Now it means this range is equals to codomain. If any function is given in this form, it means function is like R to R. It means codomain is R. If codomain is R and range is also R, so this one is onto. Okay, now choose any function of odd degree. Suppose I am taking x power 4 plus 2x plus 1. Okay, now put minus infinity. If you put plus minus infinity, we are getting plus infinity, because minus infinity power 4, now 4 is even. Okay, now put plus infinity, again we are getting infinity. Now this is the polynomial function, draw anyhow, doesn't matter, but you can't touch up to minus infinity. It means some values we can't take. Okay, na? It means range of the sun is not minus infinity to plus infinity, but codomain is minus infinity to plus infinity, so this one is into. Okay, this is the explanation for this one. Okay, na? Now you can remember. Now we will take some example to identify 1 1 onto like this one, sorry, onto into this one. So question, identify whether the function R into or onto. Okay, first one, y equals to x square plus ln x. Now you want to find that this one is onto or into. Okay, what is the method? There is only one method to check a function is onto or into, that is range. We have to find the range of this one. Okay, so can you find the range? See here, function is always a to b, but b is not given. It means I have to consider R to R. R to R, it means codomain is R. If codomain is R, then find the range. If range is also from minus infinity to plus infinity, then this is onto, otherwise into. So how can I find the range? Now actually directly you can find out that this lies from this one to this one, this one to this. Okay, then use differentiation. Okay, so anytime if you directly can't find the range, it means all possible value of y, then use differentiation. Okay, how to use? First find differentiation equals to 0, put differentiation equals to 0, from that one you will get some points, find the value of the function at these points. Okay, and also find the value of the function at end point of interval. Okay, na, end point of interval. So see, one thing is clear, that here f(x) is equals to x square plus ln x. Here we have ln x, it means function is not defined for negative x. Okay, so one thing I have to write, that x is greater than 0. You can't take x less than 0 na. Okay, so to find the range, I am getting f dash x, I am taking f dash x is 2x plus 1 by x. Okay, 2x plus 1 by x. Now one thing is clear, x is must be greater than 0, because for negative ln x is not defined. If x is greater than 0, it means positive, then this one is positive and this one is also positive, because x is positive na. So complete is greater than 0. If complete is greater than 0, it means function is increasing. Okay, if function is increasing, and what you want? Range. Range, it means minimum to maximum value. Now suppose if you any increasing function like this one. Okay, if you have any increasing function, then you will get minimum value at a starting point. Obviously increasing na, you will get minimum value at a starting point and you will get maximum value at end point. Okay, for interval a comma b. If function is, if f dash x is greater than 0, then function is increasing. If function is increasing, then you will get minimum value at a starting point and maximum value at end point. Okay, so function is increasing. Now find the minimum and maximum value. So f(x), minimum value of f(x) is equals to at starting point is 0. Now find f0. F0 is put 0 and ln 0. Ln 0 is minus infinity. 0 minus infinity minus infinity. As 0 is not included, so minus infinity is also not included. I am just only writing to explain, okay na, but minus infinity is not the value na, open interval here we go, because 0 is also not there. Okay, now maximum value of fx is at end point. X is greater than 0, end point is infinity, so put infinity. Again infinity we can't put, I am just taking only for example explanation. Okay, f infinity, if you put infinity, then this infinity power square is infinity, ln infinity is also infinity, infinity plus infinity is infinity. So minimum value is minus infinity, maximum value is plus infinity, but actually 0 and infinity both are not the value of possible value of x, so here we have to take open interval. So range is equals to minus infinity to plus infinity, that is r, so on to. Okay, if range is equals to r, then on to. Okay na, if it is given that this one to this one, then check only for that, but not given. If b is not given, it means b is r, it means codomain is r, so find the range. Okay, second one, y is equals to x square minus 6x plus, what is written, 10 by 3x minus 3 minus x square. Okay, suppose this is the question. Again we want to identify that this is this one is onto or into. Okay, so to get onto or into, I have to find the range. So first find all the possible value of y. If value of y from minus infinity to plus infinity, it means r, it means equals to codomain, then this is the onto. Otherwise if y can take values only from an interval, then this one is into. Okay, so how to find the value of y for this one? Oh, in previous lecture, quadratic by quadratic, multiply this one at this side, you will get a quadratic equation in x. Okay, then apply d greater than equals to 0. Okay, so if you multiply this one at this side, what we are getting? Y into 3x minus 3y minus x square y equals to x square minus 6x plus 10. Take all these terms at this side, take common x square, you will get y plus 1. Now take common 3x minus 3x common, then y, 2 minus taking common, so y plus 2. Okay, and also take this one at this side, then plus 10 plus 3y, okay, equals to 0. Now this is the quadratic equation in terms of x, and here I know that value of x is real. Okay, if real, it means if you solve this quadratic equation, then you will get real value of x. If you will get real value of x, if you are getting real value of x, it means real root, apply the condition of real root. Okay, that is done in yesterday lecture now. Okay, so just d greater than equals to 0. Okay, can I rub this one? I will solve it. Okay, so d greater than equals to 0, it means b square minus 4ac is greater than equals to 0. Okay, so b square is coefficient of x 9y plus 2 whole square minus 4ac, 4a is y plus 1 and c is 10 plus 3y. Okay, greater than equals to 0, d is greater than equals to 0. Now solve this one. 9y square plus 4y plus 4 minus 4 into 3y square plus 10 and plus 3 13y and plus 10. Okay, greater than equals to 0. If you solve this one, plus 9y square minus 12y square minus 3y square plus 36y and minus 39y, 52y, क्या कर रहा मैं, प्लस 36y and minus 52y. अब ये कितना होता, प्लस 36 and minus 52, 16. Okay, so minus 16y plus 36 and minus 40, then minus 4 greater than equals to 0. Take common 3, minus 3y square plus 16y and plus 4 less than equals to 0. Okay, now solve this one. If you solve this one, then you will get value of y na, and I know one thing that for this one d is okay. Suppose we have root as alpha and beta, okay, quadratic na. So suppose y minus alpha, I am assuming that root of this equation is alpha and beta, and y minus beta less than equals to 0. Okay, then this can take values. Suppose this is alpha and this is beta, plus minus plus less than equals to 0. It means y belongs to alpha comma beta. Okay, so y can take only this value na, y can take only this value, then this is not r. Okay, here if you want value of alpha beta, see, alpha beta is equals to, use the quadratic formula, minus b plus minus root b square minus 4ac. b square 16 square is 256, 256 minus 4ac, 4 into 3 into 4, okay, 48. 256 minus 48 is 208 by 2a, that is 6. Okay, so minus 16 plus root this one by 6. Okay, जो भी होगा आ जाएगा, but finally you are getting only y from alpha to beta, it means not r. So this is not same as r, so into. Okay, done. Write down. Can I have? Okay, third one. Let y equals to x square minus 2x plus 3. That is defined from 0, 3 to a. Then find a, find set a for which fx becomes onto. Okay. Now y is function is defined as x square minus 2x plus 3 from this one to this one. It means this is the domain and this one is codomain. Then find the set A for which fx become onto. Fx become onto, it means range become codomain. It means codomain must be equals to range. Okay na? So for onto, codomain, sorry, range must be equals to codomain, and codomain is A. Okay, so just A is equals to range. It means I have to find the range of this one for this interval 0, 3. Okay, then find out. Here fx is equals to x square minus 2x plus 3, and x belongs to 0, 3. Only you can take those value of x now, because this is the domain. Again I want to draw the graph of this one. This is the square. Okay na, quadratic polynomial, easily I can draw. If this one is 3 degree, then use differentiation to draw the graph, but we can draw x minus 1 whole square plus 2. Okay, now how to draw the graph of this one? That is simple. This is done in 11 now. First, this is the graph of x square, then x minus 1 whole square shift to 1 unit at this one. Okay, so this is the x minus 1 whole square, this is x minus 1 whole square. Now we have plus 2, so shift complete graph 2 unit above, so you will get like this one. When you put x equals to 1, what we are getting? 0 plus 2, 2. So this is 0 comma, sorry 1 comma 2. क्या कर रहा मैं ये? 1 comma 2. Okay ना? This is 1 comma 2. Value at 0. Find out, because we have x from 0 to 3 na. If you put 0, what we are getting? This is 1 and this is 2, so total is 3. 0 comma 3. Now find the value at 3. If you put 3, 3 minus 1, 2, 2 square 4, 4 plus 2 6. So suppose this is 3 and this is 3 comma 6. Okay, so we have value of x from 0 to 3. It means 0 to 3, so you can take only this graph. Only this graph then A is equals to range. Find range. Range is equals to, range is minimum to maximum. Minimum value this one, that is equals to 2, and maximum value, this is the maximum, that is 6. Y, not X. Okay na, 6. So A is equals to 2 comma 6. Okay, done. Okay, write down. Okay, so I have remaining some question for 1 1 many 1 into onto, okay, and bijective function. After that we'll take identity types of different function. Okay, so tomorrow we'll take, write down. Okay, कल मिलते हैं.